Some of you were confused by my magnetic declination measurement the other night, so I decided to do it part at night and part at day to make it more clear. So I've set up my theodolite laser pointer right here. It's a theodolite, but it's outfitted with a laser instead of an eyepiece, so it shoots a laser beam. And I trained it right on the North Star, which is definitely up there, but hard to find in this field of view. But I was definitely pointing at it. Oh, there it is. I think that's it right there. But anyway, unfortunately, just as I got everything all set up, it's pretty cold out, and the laser cooled off so cold it won't make anything more than a faint glow. So I don't have an immediate solution for that. But I did have it pointed at the North Star, nice and clear. And okay. So there's the theodolite. Now I've pointed it straight down. I had it pointed straight up at the North Star. That's north up there. And then I just pivot it straight down at the ground 8 feet away. So you can see I have a plumb bob set here so that I know my instrument is straight over that nail. Pretty close. Just freely swinging over that nail. So I put an aluminum nail in the ground there. And then I got this brick I can put on it to keep the cows off the nail. And then 8 feet away is where we have, let's see, can you see it? Yeah, you can almost see it. The laser is focused right onto the head of that nail. It's just, the phone is not exposing it. It's a little, oh, stupid phone. But anyway, this nail, oh, and then it decides not to focus. Bad phone. Okay, so this nail is my origin, and this nail is exactly north, exactly true north, based off of the North Star. This is exactly in the direction of the North Star. From there to there is north. So if I were over here, looking down this way, from this nail out to that nail is exactly true north, according to the North Star. Then in the morning, I can come out when it's light, if it's not raining too hard, and compare a compass to that. And I used aluminum nails, so they're non-magnetic. The exact distance doesn't particularly matter, but you can see it is 8 feet. Well, if it would focus, you could see it's 8 feet. There we go. Alright. Okay, it's a couple days later. And it's not nighttime anymore. And here's these bricks I put out here. Under each brick should be, oh, sure enough, there's a little aluminum nail right there. And under this brick, another little aluminum nail. As you may recall, a couple nights ago, I lined those up to magnetic, or true north, based off of the North Star, which was yonder up there. Okay, this is the magnetic declination here. I have this styrofoam plank on the left with its edge lined up right here to the aluminum nail, the corner here. Basically, I got these both, their corners right to the nail. And then this one here is lined up with the nail, the other nail. So this one's at true north-south along the true geographic north-south line. This one over here is approximately pointing magnetic north. So first I'm going to demonstrate here with the true north as a standard. You can see I have the compass, I have the protractor centered right on this line here. I set this to about 15 degrees, give or take. Oops. Center that right on there, and you can see that the compass is pretty much lined up with this angle, meaning that it's about a declination of around 15 degrees or so. It's kind of an inexact measurement, but you can see the idea. That's what it wants to do. Now, when we take it over to this other one, which I've already lined up at approximately the declination angle, you can see that the compass lines up pretty good with this angle here. The sun's nice but annoying. This just is all plastic, except it's got a tiny little metal pin up the center, and then of course the needle is metal because it's a magnet. That's why it's attracted to the north. Kind of jostle a little so it settles in. See, it settles right in on magnetic north. But you can see magnetic north is quite a bit to the right of true north. So if you were walking a straight line like this, your compass would be pointing north that way, but true north is this way. Give you a little foreshortening on that. And this plastic part can be aimed anywhere you want. It's just this is just, you're supposed to line this up to the needle. Actually, you're supposed to line it up with your declination like that, for example, and then that would point to true north. So like, if I go back to this one, the true north one, and point my needle to, like, let's see, that's, what are these? 5, let's see, 15 degrees would be somewhere in there like that, kind of. Anyway, there is a demonstration of true north versus magnetic north in Sequim, Washington, United States of America in 2022. And I give that information because the amount of declination you have will depend on where you are and when you are, because it changes gradually.